Hello everybody and welcome back. Root Beer here looking at question 22 on our 2018 grade 8 Gauss paper. Square PQRS has a side length 30. Oh, I was about to write it down, but I guess they have those 30s there. The square is divided into 5 regions of equal area. So this area is equal to this area, this area, this area, this area. Okay. Triangle SPT, STU, SVW, SWR, and this quadrilateral SUQV. The value of length SU over length ST is closest to. So as soon as I see closest to, I reach for my calculator. Okay, because I suspect I'm going to have to round something out. Okay, and if we take a look at the possibilities, they are to 2 decimal places. Okay, I'm thinking maybe there'll be a square root or something. I'm not sure exactly, but SU divided by ST. All right. Well, we know the 5 regions are of equal area. Now, I really want to avoid this quadrilateral if I can. I don't know if I can, but it's not a nice looking quadrilateral. It's not like a rectangle or a trapezoid. But if all the areas are the same, then this red area and this green area are the same, and they're both going to be 1/5 of the total area of the square. Now, the area of the square, it's a 30 by 30 square, so that's 900. Great. Okay, 900. So what else does that tell us? Well, the area of each triangle, or each area, let's call it each sub area, is going to be 1/5 of 900. And that's going to be 180. If you need to, you grab your calculator. So 180. Now, if I look at the red triangle and the green triangle, if I sort of separate them out away from the rest of the figure, I don't really think I need the rest of this shape. The square has done its job, and now what have I got? Well, there's S down here, there's P, T, and U. So this shape still has ST and SU in it. Now I've got 30 here, and since it's a square, we've got a right angle up here at P. And you might be more comfortable flipping this around when I say that, well, SP is a height. So here I'm just flipping it upside down, because I know a lot of people are more comfortable having their bases on the bottom. Okay. We have a height for both triangles of 30. Well, if I call, so PT is the base of, I don't know, what was it, the red triangle. So the area of SPT is going to be 1/2 base, PT, times height, 30. Well, 30 divided by 2, 15. 15 PT. But I know the area is 180. So I get 15 times PT. Length PT is going to be 12. Alright. Well, how about that green triangle? Same sort of rules apply, and it still has the same height. Just the base is a little different. So STU, 1/2 base of TU times the height of 30. But we get the exact same story, and TU is going to have a length of 12 as well. Okay, so where does this go? Well, if I want to figure out ST, look at that, I've got a nice little right angle triangle. I can figure out ST. If I want to figure out SU, well, I've got another right angle triangle. All of these triangles are right angled at P. So if we use Pythagoras' theorem on triangle SPT, we get that ST squared is going to be 12 squared plus 30 squared. And that's 144 plus 900. That's 1044. So we'll come back to that one in a moment. But we could also do the same thing on use a different color. The big blue one, the combination of these two, that's still right-angled at P. We know it's got a base of 12 plus 12, 24, and a height of 30, and SU is the hypotenuse. So, what was it? Triangle SPU. We know that SU squared is 24 squared plus 30 squared. Again, if you need to, you get out your calculator. That's 576 plus 900. So that's 1476. Now, what do we want? We want SU over ST. So that's going to be the square root of 1476 over the square root of 1044. Now, these are not nice numbers, so this is where the calculator is going to come in. I'm going to try and avoid the calculator as much as I can. I'm going to divide both of them out by 4. So I can pull out a factor of 4 from both of them. I will get 4 times 300 and... maybe my mental skills aren't quite as good as I thought they were. 2, 7, so how many times does 4 go into 27? 6 times, with a remainder of 3 and 9. There we go. Oh, I could pull a 36 out of there. We'll do that in a moment. And then pull a 4 out of the 1044. I'll get 261. Yes. Alright, but then that's going to be 2 square root of 369 over 2 square root of 261. So I can divide by the 2. I can also divide by 9. We get 9 times 41 on top. And 9, so that's 18 with an 8 and a 1, so 9 times 29 on bottom. So we're going to get square root of 41 over 29. That's as good as I can get. So now the calculator, unfortunately, has to take over. But I do try and keep my mental skills sharp. So square root of 41, about 6.403. Divided, and the square root of 29, if you're interested. It's about 5.385, and just divide the two. So square root of 41 over 29, 1.18903, and they wanted it to 2 decimal places, so we'll round up to 1.19, and that should be our final answer. I like that we didn't actually have to bother with the quadrilateral, or the other 2 triangles even. 1.19, that's an answer of B, so we're going to bubble that in, and that finishes off question 22. Up next, of course, question 23. So thank you guys for joining me. I'll see you for 23 next time.